Hi, my name is Lizzie. You may recognize me as a girl who sits under the lemon tree and does chemistry 24/7. But I am in Chem 102. I am a rising sophomore and I love chemistry. One thing about me is that after undergrad, I hope to go to grad school with something chemistry-y. And I hope to come back and be a chemistry professor, and I want to have my own chemistry lab. I love chemistry. But another thing about me is that I actually tutored people in Chem 101 since my junior year in high school. I would tutor people in 101 students at North Carolina Central University, and I would help them in their chem classes. And I know one thing that has helped people that I've tutored the most is acting as though you're in the exam when you're taking when you're like doing homework and doing assignments. Like if you have an issue, then treat it as if you're in the exam. That's how you really know if you're ready. If you're able to think your way out of it without immediately going to your notes, that's the best way to prepare you to perform well in the class. Making sure that if an issue does come up, you know how to fix it. Like you can use your knowledge to get out of your little stump. That would be my best learning tip that I've seen works. But yeah, honestly, also making people love chemistry. I mean, if you're happy to be in the class, then you're gonna want to come and you're gonna want to learn. And I want students to do that like I do. But yeah. Okay, since I would be happy to LA Chem 101 or Chem 102, I decided to do a topic that we learn in Chem 101 that we expand upon in 102, so we get the best of both worlds. So we're going to be doing some redox reactions, finding oxidation numbers, and we're going to figure out which one of these two wonderful half reactions are oxidized and which one's reduced. Yep. I have a chemical equation right here. We have lead plus lead oxide going to PbSO4. And this is unbalanced, but right now we're going to be taking a look at our two half reactions. So when I see in a question that I'm trying to figure out if something is reduced or oxidized, the first thing that comes to my mind is figure out the oxidation numbers. So that's what we're going to do. So looking at this first equation, I see solid lead. So when I see an element in its solid form like this, I know that it's going to be an oxidation number of 0. So we're going to start out with 0. Then we're going to try to find the oxidation number of this lead right here. We're going to be comparing our two leads, oxidation numbers. So looking at this side of the equation, I see SO4. I know that SO4 is sulfate, and sulfate is a polyatomic ion. And I know that this polyatomic ion has a oxidation number of 2-. So now the question is, how do we get these two sides to match up? What we're gonna do, we're gonna equate them together. We can do this mathematically and have x minus 2. We're gonna add 2 to both sides, and we get that x equals 2. Our x is going right here. You can double check 2 plus -2 equals 0. Like, it's right here. So we're equal, we're good. So now we're gonna look at our bottom half reaction. What I know from the periodic table, I can look at the periodic table and see that oxygen has an oxidation number of 2-. And as you can see, we have 2 oxygens here, so I'm going to put another 2-, or -4. What we're going to do here is the same thing that we did up here. We're going to figure out how to get this neutralized. To do that, we have 0 equals x minus 4 plus 4 plus 4, x equals 4. Our oxidation number is going to be 4. This oxidation number is -4. And lastly, this is the same as in the above half reaction. We know that sulfate has a oxidation number of 2 minus. To make this equal, we're going to have an oxidation number of 2, just like up here. So now, how do we figure out who's reduced and who's oxidized? I don't know. Just kidding. I do. We have 0 to 2 here. Looking at our, comparing our leads, here we have 4 to 2. Now I'm going to come out with a very fun thing called oil rig. Leoger can also be used, but this is how I'm gonna know who's oxidized and who's reduced. We have oxidation is loss of E minus electrons. Reduction is gain of E minus. So we're gonna look at these two, and we're gonna figure out who is losing electrons and who's gaining electrons. So this is a little funky sometimes. When you're going from a lower number to a higher number, you are losing electrons. As we see here, we're going from 0 to 2. This is us losing electrons. So I'm gonna say this is oxidation by looking at our oxidation numbers of lead. And what I see here is we're going from 4 to 2. We're going from a big number to a smaller number. So we are gaining. So it's a little funky. It's like the opposite. But I know here I am gaining electrons. So I'm gonna say this is reduction. Now this definitely comes back in 102 with galvanic cells and batteries. So this is an important thing to have a good grasp on. This is reduced and this is oxidized. So I hope you learned a lot and how fun chemistry is.